Hey, welcome to this episode on the recipe for carefree dependency management in Java projects. Today we talk about the third item in the recipe, which is defining each build concern in a dedicated file. The previous items are about how to do dependency management in a Java project. How do we define dependencies? And how do we do version management for third-party libraries? We also talked about that you use one of the build tools, Gradle or Maven, to do the dependency management, because the dependency management is part of the build tool's functionalities. Also, both build tools, Gradle and Maven, follow the convention over configuration concept, which means you can use them without much custom configuration to build a Java project. You still need at least a certain part of build configuration to tailor the setup for your needs, like configuring your Java version or your test framework. Now, as both tools have the same configuration formats for dependency management concerns and other build concerns, it is possible to mix dependency management and other configuration. In fact, it seems still to be the default way of using the tools. Many existing Java projects that use one of these tools have a mix of configuration in their build Gradle or POM.xml files. If these files grow large and you have multiple of them in a multi-module project, things often get hard to maintain and configuration mistakes may lead to inconsistencies in your setup and may have negative effects like slowing down your whole build process. But in particular, if we look at dependency management, there is a severe maintainability issue. This becomes clear when we think about who needs to work with which functionalities of the build tools. If a team of developers works on a project, they mostly work on the code. But working on the code also means dealing with dependencies, like deciding how your own modules depend on each other, following a certain software architecture that you want to enforce, but also which third-party modules you pull in which places and which versions of them you use. So the dependency management is a concern for all developers on the team. Other build configurations, though, are not something you should have to care about in daily development. Configuring tests and code quality checks that should run as part of your build is not something you need to touch in your daily work. And in large teams or organizations, this may even be done by different people, dedicated teams that take care of this. But now, if you mix all these different concerns in the same files where you do the dependency management, it becomes difficult for the developers to understand how the dependency management aspects work and how they should use them. It becomes hard to establish clear ownerships of different parts of a large configuration file. Complex build configuration, which sometimes can't be avoided for a certain build aspect, makes the dependency management look more complicated than it actually is, as developers begin to forget that the build tool they use has these different purposes and they mix dependency management with all other build concerns. That's why I think one essential step to carefree dependency management is to very clearly separate dependency definition from other build concerns. And for a maintainable build setup in general, it is also important to keep these concerns separated, hence in separated files. Let's look how we do this in Gradle first. In Gradle, configuration can be separated out of a build Gradle file of a module by putting it into a plugin. In your project, you can define a so-called plugins build into which these plugins go. How to exactly configure this is covered in my video on plugins. Essentially, you can decide for a folder where you want to put your configuration. I recommend using the Gradle/plugins folder. In here you can see that I have a number of Gradle KTS files. With this approach, Gradle offers you a number of different notations to define your configuration. I use the Kotlin DSL here, but you could, for example, also use Gradle's Groovy DSL or write your configuration in Java. The plugin we apply in our module is called Java Module, and we find this plugin here in the file with that name. So essentially, such a plugin for configuration, which is also called convention plugin, is just a Gradle KTS file. If we look into the Java modules configuration file, we see that it is a combination of other configuration files or other plugins. This is one of the strengths of Gradle's system. It allows you to freely combine as many plugins as you like by composing them. First, we apply the Java library plugin, which is a so-called Gradle core plugin. It adds all configuration to build a Java module. Everything that follows is configuration that adjusts or extends these defaults to our needs. Our Java module, for example, is a combination of a plugin that defines a set of rules for dependencies. This is the topic of the next video. A list of repositories where to pull our dependencies from. In our case, we use Maven Central, as we've seen in the previous videos. One configuration file where we put everything related to Java compilation, for example, the Java version to use. One configuration file where we configure everything related to testing, and one configuration file where we configure further quality checks, which may also contain dependency management checks that we'll talk about in one of the next episodes. This is, of course, only an example for this rather small project. In larger projects, you may have even more concerns you would like to configure. In the context of the Carefree Dependency Management recipe, I don't want to talk about the details on what you can configure here in Gradle. But if you are interested in my Understanding Gradle video series, I've already covered many of these build configuration topics in more detail. So in summary, you see that we have one file for each concern of my build setup, which allows me to keep the structured and better maintainable over time. And I have separated out all these configuration aspects from the files, the build Gradle files in my modules. There I only say, this is a Java module and please use all the configuration attached to that. And now I can reuse that in all of my modules. And when I do dependency definition directly in Gradle without the Java module system, my build Gradle file become dependency definition files. And thus, developers of the project who look at the code and the modules and not at the Gradle configuration folder can treat these files fully as part of the artifacts they work on every day. Let's have a look at how this can look in Maven and how it compares to the Gradle approach. In Maven, we also have a plugin system, but that is not considered to be used for build configuration. So it does not use a concept of convention plugins like Gradle. Instead, the POM files you use for configuring your build can inherit from other POM files. That means you have an inheritance hierarchy of configuration files. And this is what we can use to separate out build configuration concerns that are unrelated to dependency management from the POM XML files in our modules. Such a separate file is called parent POM, and you refer to it in the parent block in your POM XML. Often there is a single parent POM which is put in the root of the project. As I like the setup we have with Gradle, I wanted to see if we can reproduce the same with Maven. And I think that would not be a bad approach, but I would say it's not common practice today. What I did, similarly to the Gradle setup, is putting the Maven configuration files into a separate folder. I used .maven/config, as the .maven folder is something you may have in your project already. But as with Gradle, you could choose any location for that. Then inside this config folders, I have separate subfolders, each with a parent POM XML file. The parent of my modules is the Java module/POM XML. So the same names that I used in the Gradle setup. And now to separate each build concern into a dedicated file, I use the hierarchy of parents. So the Java module POM XML has the quality check POM XML as parent, the quality check POM XML has the test POM XML as parent, the test POM XML has the compile POM XML as parent, and the compile POM XML has the repository POM XML as parent, which has the dependency rules POM XML as parent. Also, this does not seem to be very common. Often I see users avoiding this and having a single POM XML and then separating the build concerns by having blocks in a very large XML file, which is also something you can do. It's not exactly putting each concern into a dedicated file, but at least you put all non-dependency management related concerns into one dedicated, well-organized file, which in the context of carefree dependency management is good enough for that aspect. The limitation of the parent POM approach, which allows each POM only to have one parent, is, I think, one of the disadvantages of using Maven over Gradle. It makes it quite hard to organize build logic in larger builds in a nice, maintainable way. For Maven 4.1, it is planned to add a so-called POM mix-ins concept, which allows you to combine several POM snippets into one. So essentially offering a POM aggregation approach in addition to the POM inheritance approach that you have with the parent POM. For now, if you have a Maven build, I think the most important aspect is to keep build configuration out of your module's POM XML files, so that, similar to what we saw in Gradle, the developers that work on a module can fully own the POM XML file, as it now is purely the dependency definition file and does not cover other build configuration concerns. In summary, point 3 of the recipe is really about doing a clean separation between the two aspects the build tools cover, the dependency management tooling and the actual build tooling. It's about isolating the specification developers need to do for dependency management, which is defining the dependencies between modules and the management of third-party versions, from everything else that needs to be configured for the build tool. Making sure that dependency declarations are cleanly separated for anything else you might have in your repository that configures Gradle or Maven. In the next episode, we'll get back to the dependency management topics and look at how the build tools help you to discover and resolve conflicts between third-party modules. And we explore in which cases you need to do some custom configuration for this and how to do that in Gradle or Maven. See you then.